Do you guys recall what this graph looks like? E to the power of x usually looks like this. E to the power minus x will look the other way, right?
Yeah.
Like that. So we're actually only concerned about 0 to 2. At 2, it's going to be 1 over e squared, so it's a really small number. Okay. 1 over e. So we're looking for this area here. Okay, so midpoint. So on purpose, I'm just going to cut the interval into really big pieces. Okay. This is just dot 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 to say there's a lot more in the middle there. Okay, so what's the delta x in this case? The delta x is always the interval divided by the n. So 2 over n. Okay. Now where do you take the first height? In this case, we don't take it the left or the right, you take it in the middle. Now, there's a good reason for that. Because in real life, this is actually, if you actually, in real life, we do this with a computer, right? And you want the computer not to do so much work and still get a pretty accurate answer. Compared to left and right, look at this. Wouldn't this sort of give you a better result right off the bat? Because it's a little bit of overestimation and a little bit of underestimation, so they sort of cancel each other out. Okay. But for hand calculations, the right hand and left hand is easier. Okay. But in the computer, when you're programming it in, this is better. So what is that first interval then? Okay, let's write the next one. Right. What's this one going to be? Right. Because you got to add another 2 over n, so 3 over n. Okay, you see a pattern emerging, right? The number at the top is going to be an odd number. Right. So what about the last one? What is the last one going to be then? It's going to be 2n minus 1 over n. Okay, so that means we're going to be our area approximation is going to be delta x times by the first height is taken at 1 over n. Second height is 3 over n. Right, and the next one's going to be pattern continues 5 over n. All the way up to f at 2n minus 1 over n. This tells me it's this. Sigma I is equal to 1 to n f at 2i minus 1 over n times by delta x, which is 2 over n. Okay, so you can always get what you need to put here once you figure this last term out. It's the same pattern, right? Okay, so the area then is equal to limit n approaches to infinity. I is equal to 1 and yeah, so it's e to the power of minus of 2i minus 1 over n times by 2 over n.